The objective of the Healthy Pet is to provide a user-friendly alternative method for pet feeding for busy shelters with limited staff members or homeowners on the go. The main deliverable is to have the Healthy Pet operate at the palm of your hands. The Healthy Pet is expected to dispense different amount of servings, dispense the food to the correct animal, input a pet profile for each animal, and safely and efficiently provide power with an optional alternative power source.
The Healthy Pet application will store data to an online database through Wi-Fi. The app will also control the microcontroller through a Wi-Fi connection. The microcontroller is programmed to run Python scripts to turn on the stepper motor, which is integrated with a load cell to make sure the correct amount of food is dispensed. Finally, to protect from any surges, it is all powered safely and efficiently with automatic power supply switching, along with an optional solar power source.
Here we have the 3D model designed in SOLIDWORKS. The actual enclosure itself is made roughly 50% by laser cutting and 3D printing using SOLIDWORK files, and 50% made by hand with a labor of love. The power subsystem has two different aspects. One is provide power to the microcontroller safely and preventing any voltage spikes that go above the safety range of the microcontroller. Here you can see the Pi being run as normal through a standard USB outlet, but in the event of a power surge, you'll notice that the Pi is safely protected, and thanks to the resealable poly fuse, there's no need to worry about blowing glass fuses. The second aspect, being the automatic power supply switcher, is put in place to appropriately protect the solar panel. You'll notice that the solar panel is currently charging the battery, though having a hard time getting the necessary current from standard light. When the power is provided from a USB outlet, you'll notice that the power generated by the solar panel has been completely cut off, and when it's unplugged, the solar panel instantly provides power again.
The weighing subsystem performs the behind-the-scenes tasks of weighing the dispensed food to deliver the data to the Android app. It consists of a load cell, which compresses slightly under the weight of the food bowl. This is sensed as voltage deviations in the HX711 combination amplifier and analog-to-digital converter. The resulting digital signal is sent to the Raspberry Pi through its GPIO pins, where custom Python logic has been written for the Pi to activate the HX711 and use its internal clock to perform weighings. The load cell has been mounted to a load plate to facilitate all weight in the bowl to be concentrated into a small area on the cell, as this allows for precise measurements to be delivered to the user through the Android application. Through this combination of hardware and software, weights delivered to the app are less than a single percentage off their actual values, allowing for the motor to dispense the food only when needed, and thus allowing for the user to deliver exactly the quantity they want to feed to their pet.
One key feature of the Healthy Pet is the non-contact access control subsystem. It contains a ultra-high frequency reader that sends a 13.56 megahertz frequency signal to a passive tag. The tag is powered and attenuates a signal back, which is what is being detected by the reader. Each tag has a unique identifier, which is converted from a byte array to a string. The reader transmits and receives data to the Raspberry Pi using UART communication. The string extracted from the tag is used to specify the restricted tags from the non-restricted tags. Once the correct pet approaches the food bowl, their tag will be read and then will prompt a lid to open. The lid's rotation is due to a continuous servo motor that is controlled through pulse width modulation signals. This controls the driver pin of the motor and determines the motor's speed and direction of rotation. The dispensing subsystem is the integration of the mobile app, weight data, and stepper motor control. The script begins by taking in weight sensor data from the load cell beneath the dog bowl. From the mobile app, the user will select what measurement to be dispensed. As long as the weight measured in the bowl is less than this target weight, the motor will be prompted to spin. The motor uses interleaved stepping in order to maximize torque and accuracy.
The Healthy Pet application allows a new member to register upon the opening of the application. Once registered, the user is then prompted to register a new pet. When registering a new pet, some basic information will be asked to be input, such as the name of the animal, weight, its age, and more. Once the user has successfully registered the pet, the user will have the option to check the amount of food left by clicking the reservoir button, dispense food by clicking the dispensing button, or go back to the profile of the animal or select a different pet.